Hello geometry students, here's your lesson for section 2-1, using inductive reasoning to make conjectures. Missy McCarthy, Oakman's High School math instructor. By the end of this section you should be able to say I can use inductive reasoning to identify patterns and make conjectures, and determine if a conjecture is true or false and provide a counterexample if it is false. What do you know? Let's try a little activity to get your brain warmed up. In the following examples, you'll be given a logical sequence of 5 boxes. Your task is to decide which of the boxes completes the sequence. To give your answer, select one of the boxes marked A through E, and then at the end, I'll tell you the answers and we'll find out if you are correct. So here's your first one. Pause it if you need to. Look at the top sequence of 5 boxes and then select which one would come next, A through E. Here's question 2. Look at the series of boxes at the top, 5, and then select A through E, what would come next. Here's number 3. Again, pause if you need to. Here's question number 4. And here are the answers. Hopefully you put E for question 1, D for question 2, D for question 3, and B as in boy for question 4. So what you just used in order to figure out some of those was something called inductive reasoning. And the items that you looked at were from an inductive reasoning test that measures your ability that are important to solve problems. So they measure how you work with flexible situations, unfamiliar information, and how you find solutions. So people who perform well on this test tend to have a greater capacity to think conceptually as well as analytically. Now, if you didn't perform well on this test, it's totally okay. You didn't know what you were taking. But it's just to show what inductive reasoning is. So when you look at several examples that form a pattern, and you assume that that pattern will continue, and you make a rule based on that, you're applying what we call inductive reasoning. You may use inductive reasoning to draw a conclusion based on a pattern, and that's all it is. It's a process of reasoning that some sort of rule is true because it's true for specific cases. So let's use some inductive reasoning to identify a pattern, and then when you come up with a rule for that pattern and you make a statement, that statement would be a conjecture based on the pattern you see. So we're going to find the next item in the pattern. January, March, May. What would come next? Well, it looks like they skipped February and they skipped April. So if May came next, I'm assuming they're going to skip June, and I assume that my next one is going to be July. So I just made a conjecture based on inductive reasoning. Here we've got 7, 14, 21, 28. My assumption based on the pattern is that they are counting by sevens, and I am going to make a conjecture that the next item in the list would be 35. And then lastly, we have a triangle pointing up, a triangle pointing to the left, a triangle pointing down. I am going to make a conjecture based on the pattern using inductive reasoning that the next triangle would be pointing to the right. And I guess my picture isn't that. There we go. That's a better picture. So I just used inductive reasoning to identify patterns and make conjectures. Okay, so when you make a conjecture is nothing more than a statement that you believe is true based on inductive reasoning. Similar to when your aunt comes up behind you every time she sees you and she covers your face and says, "Guess who?" And you guess, "Oh, it's Aunt Joan." You have been using inductive reasoning and you've made a conjecture. Okay, so we're going to use inductive reasoning to make some conjectures here. The product of an even number and an odd number is always what? So in order to do this, I'm going to multiply some even numbers and some odd numbers. So 2 times 5 is 10. I'm going to do 4 times 7, which is 28. Let's do some more. Let's do 6 times 3, which is 18. And I notice that all of these numbers are even numbers. So that is my conjecture. Based on this inductive reasoning pattern that I found, the product of an even number and an odd number is even. So let's make a conjecture for the next one. The number of segments formed by n collinear points is blank. All right, so I'm going to start off with 2 collinear points. So here's 1, there's 2 collinear points, and I was able to make 1 segment. Now I'm going to do 3 collinear points. 1, 2, 3, and I was able to make 2 segments. Now I'm going to do 4 collinear points. 1, 2, 3, 4, and I was able to make 1, 2, 3 segments. So if I have n collinear points, it looks like the number went down by 1 each time, so I would be able to make n minus 1 segments. That is my conjecture based on inductive reasoning. I want you to be careful with some of these patterns that you're looking at, because some have more than one correct conjecture that can be drawn. For example, the pattern 1, 2, 4 can be extended with an 8 if you think about multiplying each number by 2, or it could be 7 if you think about adding the consecutive numbers to each term. So think about that when you are making your conjectures. Make sure you have enough in your pattern to come up with the correct rule. When you have a conjecture and you want to show that that conjecture is true, you would, for all cases, you would have to do something called proving it, or you would have to prove it. We're going to talk more about proving things later. But for now, if you want to show that a conjecture is false, you would have to come up with one example for which that conjecture is not true, and that is called a counterexample. A counterexample can be a drawing to show that the conjecture is not true. It could be a statement, or you could simply use a number to show that the conjecture is not true. So let's practice coming up with some counterexamples to prove a conjecture is false. So here we go. We have for every integer n cubed is going to be positive. So is that ever true? Sure, it's true. If I choose the number 2 and then I do 2 cubed, that's a positive number. That's 8. If I choose the number 1 and I do 1 cubed, that's a positive number, which is 1. But is that true for everyone? No, I'm going to come up with a counterexample. I'm going to say if my integer that I choose is -2 and I do -2 cubed, my answer is -8. So this counterexample shows that that conjecture is false. I came up with a number for which that doesn't work. Here's the next one. 2 complementary angles are not congruent. Okay, so what does complementary mean? It means they sum to 90. What does congruent mean? It means their measures are the same. So can I come up with 2 complementary angles that are not congruent? Yeah, 30 and 60. So that's true. But in order to prove that it's false, I have to come up with a counterexample, an example where the 2 complementary angles are indeed congruent. And so my counterexample would be, hey, what if those angles are 45 degrees and 45 degrees? So I just came up with a counterexample that showed that that conjecture was false. The last one says, based on the data in that example, the monthly high temperature in Abilene, Texas is never below 90 degrees Fahrenheit for 2 months in a row. So I'm just going to look for 2 months in a row, and I don't have to look far to find my counterexample. Here are 2 months in a row right here. where the temperature is below 90 degrees, and so that would be a counterexample to prove that that conjecture is false. Okay, so at the end, make sure that you can identify or use inductive reasoning to identify patterns and make a conjecture, and then determine if a conjecture is true or false and provide a counterexample if it is false. See you for more practice in class.